Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to the Asynchronous DeFi session of the Supernova Hackathon. We have people from all over the world watching this truly global event. It's now 8:20 in the West Coast in the USA, it's late afternoon in Europe, and almost midnight in China. So what's asynchronous DeFi? Simply put, asynchronous DeFi is DeFi on a blockchain with an asynchronous communication model like the internet computer. This asynchronous communication model helps the internet computer to reach limitless scalability by canisters being loosely coupled by asynchronously sending messages. This helps us have a foundation for building perfectly scalable real-world DeFi applications. So DeFi is not anymore constrained by the usual typical constraints we have on other blockchains, but you can scale and build real-world equivalents of real-world DeFi applications on the internet computer. But this asynchronous architecture also poses some challenges because it's a different implementation model than what people are used to from other blockchains. And I'm so happy to see that many projects have taken on the challenge and implemented and submitted very, very nice, exciting projects to the Supernova Hackathon, and we selected 7 of them, which we are showing today. I'm Dieter Sommer, and I'm part of the research team of the DFINITY Foundation, and I'm very happy to be the moderator of the Asynchronous DeFi session. We have 4 judges who will score the projects that are being presented, namely Hao from SNC Holding, John from Polygon, Lexi from IC Board, and Elvi from Chainlink Labs. Already a very big thank you to all the judges for doing this great job. The following projects have been selected as finalists for this session. First, the Portal Creator Marketplace and the Beam Payment Protocol, the IC Transaction Coordinator, or Ictc, the Enoki Decks, Finterest, Tonic, Earn, and Interesting NFT Protocol, and Spinner Cash. And this is also the order in which they will be presented. We received so many more exciting projects, and we had to narrow down to a selection of 7 projects, which are now the finalists of this session. And I would like to say a big thank you to everybody who has spent lots of time to write cool DeFi projects on the asynchronous internet computer and to prove that DeFi is very, very possible on the internet computer, and actually that the internet computer is a very great platform for doing real-world DeFi applications. Some rules for this session. So each presenter has 6 minutes for doing the presentation. After each presentation, we have 3 minutes for Q&A session with the judges. The general audience cannot interact with the teams. And please be mindful of the time, because once your time is up, we will make a hard cut because we don't have any spare time for the projects to present. And also, please, judges, fill out the scoring board until the end of the last pitch so that we can then decide on the winner of the session. One more thing, the session is being recorded, and only the panelists will be visible and audible in the recording. This concludes my introduction, and we can open up the stage now for the demos. The first project is by the Portal team. So Portal team, please, the floor is yours.
Hello, good morning, everyone. Thank you for this incredible opportunity. I'm really excited to be here and represent Portal for this hackathon. It's been an awesome experience. At Portal, we've adopted the rule, show, don't tell, because we feel that walking you through a fully working, scalable web app is a million times better than showing you some slides with a bunch of text. Okay, what I'm showing you is the world's first video streaming platform running completely on-chain. Other video projects have made this claim before, only to state later in the next paragraph that their media is actually stored on IPFS or on Amazon. What this means is that 99% of their platform is actually not stored on-chain. At Portal, we store everything 100% on the blockchain, including all of the media assets. As you can see here in the creator dashboard in the storage system, we have several smart contracts which each contain the required video segments to play the video. But Portal is more than just a true native Web3 video platform. It's a platform with video quality comparable to Netflix or HBO, built for creators to solve the major problems that Web 2 does not have the ability to solve. As you can see here, the videos play in real time, streaming directly from the Internet Computer blockchain. In addition, we have access to all of the features you'd expect from a high quality streaming application, such as the ability to change qualities, select different bit rates, select different playing speed, and seeking anywhere in the video. Portal offers a no-code platform for uploading, managing, monetizing, and distributing revenue. Because of the Internet Computer technology, Portal is able to offer creators an unheard of 98% of their revenue. In comparison, YouTube takes 45% of its creators' ad revenue and forces its users to use other apps like Patreon to provide additional revenue streams. Portal also offers film projects a better way to get funded, while helping the project develop the community and recognition required to enter into a blockbuster Web 2 deal if they so desire. Smart contracts on the Internet Computer manage all IP and royalty distributions in real time. Waiting 2 years to receive royalties is a relic of Web 2 and a strong indicator of a broken and inefficient system. Using Web3 technology, Portal has not only solved this issue, but we've also developed a reward system to incentivize a project's earliest and most devoted fans, leading to a strong and loyal community. Reward especially strong comments, reviews, and referrals with tokens or NFTs. There are two things I want to demonstrate that make Portal so revolutionary. The first is the fully built-in monetization options. Renting, purchasing a subscription, or watching an ad each generate revenue for the creator and the royalty token holders. The second thing is the ability to bootstrap your channel by selling royalty tokens to keen investors who will then receive a % of all revenue generated on the channel. You can see here an advertisement playing on the channel. And as a result, a transaction occurs which pays the channel creator directly, after which that payment is distributed to the royalty token holders. To demonstrate this, I'll show you here in my plug wallet how I have 2 Supernova royalty tokens, which entitles me to 2% of any revenue generated on this channel. Looking at the activity here, we can see that there is indeed a transaction here, a 5.05 ICP where I rented a video, followed directly afterward by a 2% return, which is the royalties being dispersed in real time. If I click on the transaction and follow it through to the channel's account, you can see here that there have been 708 royalty transactions, and all of them have been very small microtransactions. And as you can see here, they occur in real time. In conclusion, creators we're working with are incredibly excited about the ability to retain 48% more of their revenue. Fans are excited about the ability to find fresh new content and to engage in communities where they're rewarded for their support and early adoption. And investors are incredibly excited about having access to a brand new asset class that offers immediate returns each time a transaction occurs on the channel. There's a saying that tech needs to be 10 times better to drive adoption. We're offering creators the opportunity to double their take rate, access to a new asset class, and an incalculable speed up in payouts for investors and royalty token holders. Thanks once again for this opportunity, and I'd love to answer any questions.
Thanks a lot again, Jesse. We move on to the next one. It's the Beam payment protocol by Contentfly. The floor is yours.
Sure. Okay, so it's Sam and Henry here from Contentfly and the Beam payment protocol, which was developed in the last 4 weeks. So if we go to the next slide. So what is the problem? Well, in traditional kind of arrangement, workers are still paid at the end of the month. And, you know, why is this so? It's uncontested and unchallenged for thousands of years. So from the payment end coming in, workers, the cash flow is kind of a little bit more difficult, and then paying out to services and those kind of things, they have to pay up front. So workers are really squeezed in the middle. So with these lump sum payments, one party always has an advantage of overutilizing this capital. And also time is money. So, delayed utility of this capital decreases economic efficiency in a system. So the solution, well, Beam. So it's a real-time streaming payment for content creation jobs on Contentfly, which will be live in July. And in the future, it'll be a protocol for third-party integration for developers to build on top of and integrate, and for parties to then stream payment into third-party services or vendors. So why now? Well, the internet computer is ready. The integrations are coming soon, and blockchains require this utility for widespread adoption.
Yeah, so our team has both of us. So my name is Henry, and then we got Sam as well. So I'm a lead software engineer, and Sam is the product manager. So we're both co-founder. We are pretty lean team, and we combined. We have 30 years experience on startup. So we've been working together in the Contentfly project for 12 months. So now we move to the next slide. So we're going to start the demo. We'll switch to the demo. So what you're looking at is the Contentfly app. So this is the creator view of the job. So we have been payment integrated, and you can see, so the ICP token is changed because, so what happened is we have to buy a deposit to the escrow. So it's 100% FI ICP. In the escrow, and then it's now being in real time to me. So you can see this changing, and the creator can claim funds. So I've claimed a certain amount here, so you can see the changes. And so if you click fund, then I can claim from the prop wallet. So that's it for the demo. So I'll move to the next
So we
slide.
believe workers receiving the streaming income will be commonplace in the future. Here's our vision of the ecosystem in the future. So you've got employers or buyers paying over streaming payment to workers or creators, whether that's employers, employees, or a contract type role. And instead of the employer just being able to utilize the capital and pay for someone at the end, it's streamed to them, and both parties will be able to utilize that capital stored in a smart contract through vendors or service providers through integration via an SDK, either upstream or downstream on Beam or on the third party's kind of app. So these are kind of some of the things you can imagine that could be utilized by either of the parties and stream money straight into these services and utilize it in real time. So things like, what was talked about before, which is like streaming video content. You could pay for the actual time that you watch as opposed to just paying lump sums and those kind of things. You could automate money going to savings buckets, donating, investing in a dollar cost average way, or even traditional things like renting, building, transport. So these for streamed or long duration services that we think will fit well. So the roadmap and go-to-market strategy, as we said, July 20, in just about a month or so, Beam will be live on Contentfly. So Contentfly is a kind of content, a Web3 job marketplace, a job management tool and marketplace. So it'll be an option for a buyer, either a lump sum or a Beam payment to a creator. And we plan to onboard other internet computer teams to test in this. That'll be the first time that payment will be going live on our Contentfly platform. After seed funding on 6 and then 18 months post, we plan to split off Beam into its own standalone Contentfly website for people to, other teams to pay their employees or creators in a streamed manner and have some basic functionality with that. And then at 18 months after funding, we plan to have an SDK where developers can build on top of, and then we start to integrate those kind of services and those vendors, and also extend on the business cases of Beam and the functionality of it. So the funding to unlock these things, we'll put into 3 different categories here. So you've got half a million, 1 million, and 2 million, and that really depends or determines how much we're able to do. So as we talked about there, the first one is that splitting off it onto its standalone platform, getting things like security audit, which we want to definitely do and make it a priority. At that middle stage, we'll be able to develop the SDK and have developers building on top of it. And then at the last one, we'll a full ecosystem with an app marketplace, a token for management and earning, and potentially a native mobile app. So that pretty much finishes our presentation. Hope you enjoyed it. Check out our website, contentfly.app, on Twitter, contentfly app as well. So thanks for your time.
Thank you.
So thanks again,
Thank you.
Henry and Sam. Great presentation. Next up is Ictc, the IC Transaction Coordinator by IC Lighthouse. The floor is yours.
Hello, everyone. I'm from Ictc, and I will introduce Project Ictc on behalf of the IC Lighthouse. I will project our project from the following aspects: problem, solution, benefits, and demo show and roadshow and team. I will invite all of you to think about why there is no outbreak for DeFi application on IC. And we believe the reason is the biggest challenge is we have to deal with the atonicity on IC. And so we believe the IC does not guarantee right now data consistency in cross Canister transaction, and there is no transaction log for Canisters, and the difficulty for the technical implementation. So our solution is IC Transaction Coordinator, Ictc. This is a distributed transaction framework for DeFi application on IC network. It consists of 3 parts: transaction manager, task aggregator, and transaction composition. And transaction manager is used to specifically manage transaction orders, and task aggregator is used to perform specific tasks, and the execution will definitely return a result regardless of success or failure. And the transaction compensator is used to perform compensation operation for abnormal transactions. So Ictc right now supports two modules, Saga module and 2PC module. The Saga module callers pushes the task function and the corresponding compensation function into Saga Transaction Manager. These tasks are executed orderly, and the transaction is complete if all the tasks are successfully executed. If one of the tasks returns an exemption, and the transaction is recovered by executing the compensation function from the previous task in reverse until the compensation function of the first task is complete. And if no compensation function is provided, or if there is the exemption is raised again while performing compensation, the transaction will be in the blocking state, waiting for the governance contract or the administrator to perform manual compensation. So each task of the 2PC module needs a complete to prepare function, the commit function, and optionally the compensation function. The callers pushes the task into 2PC transaction manager, and which first executes the prepare function of each task in synchronous, and the commit function of all tasks if all the prepares return yes. If at least one task prepare return no or exception, the compensation function corresponding to all tasks will return yes, will be committed, and the transaction is abandoned. So Ictc is an open source distributed transaction development framework provided in form of Motoko module, and developers can leverage it to quickly build their DeFi apps. Right now, Ictc has currently implemented the Saga module and is being applied in DeFi projects. The modules we provide to developers including code type, SynTA, ACTA, Saga TM, and TPC TM. Also, we have developed a delicate Ictc management interface so that we can be used to view transaction logs, as well as for the governance and manual compensation. Our benefits, we believe, for the IC, for developers, it provides an infrastructure for the DeFi application development and lowers the technical barriers for developers. And it also provides a solution to cope with administrative problem of IC network. and it become possible to complete a large DeFi application on IC, which will promote the explosion of IC ecosystem and IC DeFi applications. For the community, the management and the governance of transactions through Ictc promotes the security and reliability of DeFi applications. So you can check out the examples of our Ictc usage on GitHub. We also provide Ictc transaction viewer. Let's take a look at our demo show. Please enjoy.
We provide a UI for viewing and managing Ictc transactions. You can view a normally completed transaction, including its executed tasks. You can also view a transaction that encountered an exception and was successfully rolled back with the status recovered. When a forward mode transaction encounters an exception, or when a backward mode transaction encounters an exception on rollback, the transaction is in a blocking state and requires governance or manual compensation to complete the transaction. The Ictc UI provides an interface for managers to compensate transactions for operations such as removing tasks, appending tasks, and executing completion transactions. Managers need to be prudent in handling compensation operations, which can introduce problems such as breaking data consistency and leading to centralization. A way to circumvent these issues is to give permission for compensation operations to a governance smart contract rather than to an individual manager.
Okay, thank you.
Thanks a lot. So this concludes this session, presentation. Now let's next get to the Enoki Decks by the Enoki team. Please go ahead. The floor is yours.
Thank you for that. So, hello everyone. My name is Rudy Haspin, and I'm a software developer at Enoki. So let me show you what we've been working on. We are building yet another crypto exchange. So over the past year, only 3% of the global crypto trade volume has passed through decentralized exchanges. The rest has passed through Binance, Coinbase, and other centralized exchanges. And we want to fix that. So the problem with centralized exchanges, you know what they say, not your keys, not your crypto. Coinbase recently warned that it could take users' crypto in the unlikely case of bankruptcy, which just sounds crazy. And you probably heard about Celsius freezing all account withdrawals. This would not be possible in a non-custodial decentralized exchange. But now, why haven't existing decentralized exchanges really caught up yet? We think one of the main reasons is gas fees. Not just they're high, but also having gas fees requires onboarding your clients and your users. You have to teach your users what gas is, what utility tokens are, and how to pay for gas fees. And another core issue we think is regarding the AMM model. This AMM model is executed in a synchronous manner. So each user transaction is executed one after the other. And then this is just not scalable. And so for these reasons, we have created Enoki Exchange. We are leveraging the Internet Computer's reverse gas model and asynchronous scaling to create what we hope to be the largest and the easiest to use crypto exchange. So this is how it works. We have one exchange smart contract or canister and many broker smart contracts or canisters. Users can submit limit orders to a broker, and the exchange is in charge of periodically synchronizing the broker state and executing the transactions. So this allows for a trustless exchange with zero gas fees, and this exchange is infinitely scalable because you can just keep adding new brokers. Let's see what this looks like. So this is our app. You can submit a limit order here, and it gets added to an order book. Now, this is important because it also gives you some pricing information. You can see the prices in red are the prices at which you can currently buy this token, and the prices in green are the prices at which you can currently sell this token. And so the exchange can synchronize this order book between all the brokers. And so each broker now has access, this broker smart contract has access to an order book, and it has access to funds from a liquidity pool. And now this allows brokers to execute swaps locally without having to communicate with an exchange or with other brokers. This allows swaps to be more scalable and faster. And this also has a nice property that these liquidity pool funds are executed at these prices with this bid-ask spread. And these prices move with the market. This means that these funds are not subject to impermanent loss. Let's see what this looks like in a quick demo. Okay, so this is our app. Here's my wallet. We can mint some test tokens, and I can swap here. This is my expected price. And again, I'm swapping and I'm only communicating with my assigned broker smart contract. And now the swap is successful. That's it for swapping. And then here I can add and remove liquidity from a liquidity pool and earn some rewards this way. And here I can submit some limit trades. Let's see if I change the price to this and I submit the order. The order gets sent to my broker, and then it's eventually the exchange synchronizes it. Here's my order down here. And then eventually ends up here in the order book. Now, because my order was posted to the order book, I am now making a market. I'm a market maker. And if this order is executed, I don't pay a fee. As I think it was just executed, I don't pay a fee. And instead I get a something that's called an exchange rebate or a discount. Sorry, here's my order still here. I get an exchange rebate or a discount on this amount traded. And we're also working on providing more incentives for market makers to keep an optimum bid-ask spread that's not too small, depending on the price volatility. You can read more about our incentives in our documentation. But for example, every time there's a swap, I'd get a small extra market maker reward before providing this service. And that's our app. Now, quickly about our team. We are a team of two. Both of us have previous fintech experience, and we're looking to keep growing our team and to collaborate with the IC community to build a scalable DeFi ecosystem. So thank you very much for your time. You can try out our, look at our website and try out our app at these links. And now I can take some questions.
Thanks a lot, Rudy. Exciting presentation, cool product. Any questions from our judges?
Well, I can just add, we also have a trading bot here. You can clone and start testing with the test tokens. And this is this is what's currently running here and making all these trades. So try it out.
Cool, thanks again. Questions?
Yeah, so thank you, Rudy, for the presentation.
Mm-hmm.
Quickly, if you guys are you guys live?
Yes, I'm live.
Nice. How many daily users do you guys have?
Oh, sorry, no, I thought you meant the presentation. No, we're not live yet. This is a testnet.
Oh.
Oh, sorry, these are test tokens.
Yeah.
And we built this all for Supernova. So this is 4 weeks of work. You can mint some test tokens and try it out here.
Nice. And
it's really nice.
Yeah, it's very cool. And are there any potential risks that could be introduced by having the brokers kind of like in the middle of the trade here?
Yes, absolutely. This is why we didn't want to go live just yet, because the simple AMM model, the AMM model that's used right now, it's very simple and it's very it's very easy to use. This model, since we're scaling and we're having asynchronous scaling with all the brokers, there has to be synchronization of state, and just the complexity goes up a lot. And so we want to keep testing the app before we're ready for for going live. But our initial tests show that it is indeed scalable. Yes, and not only do we need to scale this exchange, we also need to scale the token. We also built a proof of concept token that's scalable. This token has a sharded user accounts, which allows for parallel asynchronous transactions. And so again, we want to scale the whole DeFi ecosystem. So I think it'll take a little bit of work before we can actually go live.
Cool, thanks again, Rudy. We're out of time. Moving on to the next presentation by Finterest. The floor is yours.
All right, hello. Thank you guys for having us today. It's a pleasure to be here. I'm Carl Sachs. This is Oliver Barr. We're the co-founders of Finterest, which is a borrow lending protocol on ICP, supporting native Bitcoin. We did prepare a demo today. I do want to get into it pretty quickly here. So I'm going to share my screen. We'll get right into it.
Hello, everyone. I'm Anders, the lead developer at Finterest. I'm going to be showing you what we have right now. So as you can see, I have a bunch of ICP supply already. I have 2 ICP balance. I'm actually going to go to history, and you're going to see that every transaction of Finterest is logged in Canister, completely in-chain. So that's pretty cool because, you know, it's stored. You can query whenever you want to. So what I'm going to do now, I'm actually going to supply Ictc, which is the other asset we support right now at the moment. I'm going to supply 3 Ictc to a protocol. Right now I have some ICP, already supplied. So I'm actually going to prove the Ictc, and you're going to see how fast this is. This is very, very fast. It's going to take under 10 seconds to 20 seconds for all. You're going to see it's really, really fast. And it's going to give me my corresponding F tokens. And F tokens are basically the way we accrue interest on your underlying assets. You can see I have 100 of FICP tokens. I'm actually going to refresh it now, and you're going to see I have it on the Ictc balance as well. So I'm going to refresh it. While that loads, I'm actually going to borrow. Well, if I try to borrow right now, it won't let me borrow because I have to specify that my Ictc is a collateral. And usually we'll be done with this switch, but I have to call it manually. So as you can see, we also have a price oracle we made ourselves in Rust. This is a functioning price oracle that's like updating the Canister value based on, using a private key, and it's actually updating in real time. So that's pretty cool because liquidators will be able to see price fluctuate very fast, and they will be able to liquidate loans, or underwater borrows, almost in real time. So as you can see, it worked. Right now I'm using my Ictc as collateral, and I'm going to borrow 0.10 ICP against that Ictc. So I'm going to allow the canisters. This should be very fast. So usually, transfers out of the canister are very, very fast, it's pretty cool. So while this is happening, I'm going to show you. I'm going to move my camera to the left, and as you can see, I actually have 150 Ictc tokens, and you're going to see that this value accrues interest when people interact with the protocol. And you're going to see, actually the borrow went through. You can see my borrow balance went up. I have a net APY of 0.06%. My balance is up. The APY changes in real time. Right now I have a 0.22% APY in my ICP lent. So it's pretty cool because that means the interest rate model is working flawlessly. So I'm going to repay the borrow I just do. And the way we process ICP payments is we built our own payment infrastructure based on that scales horizontally based on the invoice Canister designed by Calpica. And it's a very good design. And the way we post it is to make it interoperable with Bitcoin. So once Bitcoin is live on our computer, mainnet, we have played with the net review. Actually, I'll show you a little video. I'll have a video in a while. But basically, when Bitcoin is live in mainnet, ideally it should be us changing like 2 or 3 lines of code and making Bitcoin, processing payments with Bitcoin a breeze. So this is probably almost done now. Let's just wait for it to finish.
We'll add that this is on mainnet as well.
Yeah, because plug sometimes I have to refresh it, so it's going to take a couple of seconds to show. There you go. As you can see, I paid my borrow, so I have 0% right now, 0% APY, $0 of borrow balance. So just what I'm going to do now, I'm actually going to withdraw some of my FICP. So let me see how much I have. So I have 100 FICP. I'm going to actually withdraw 20. You're going to see that the values change, and it's actually going to convert my FICP balance. It's going to take 20 out of that balance, convert it to ICP, and send it back to me. See, let's wait for it to finish. There you go. You can see it's pretty fast, actually, really fast. And my balance changes, everything's changing in real time, including APY. So the interest rate model works. I'm actually going to refresh the wallet so you can see that the FICP balance actually went down. You can see that I actually have 80 now. I had 100 before. So also this balance will increase as long as people interact with the protocol and some interest is accrued. So usually, as people borrow and interest is paid, this number will go up as well.
All right. Now we're going to head over into the Bitcoin demonstration.
Hey, so here's a quick demo of how our Bitcoin canister works. So we have a Bitcoin layer 1 address with some Bitcoin, and then we have a canister that can generate Bitcoin addresses as invoices. right? So we're going to do that. And how it works is you send Bitcoin over from whatever address you want that has Bitcoin over to this layer 1 address, and that's been generated as an invoice by Canister. And then you can mint the Bitcoin over on the ICP network, which will be a DFINITY, but the whole point is it's backed by layer 1 Bitcoin, which is really cool. That's really innovative. And yeah, so it's an address. And then the cooler thing is that once it's a DFINITY token, the fees actually can be zero if you want, if you subsidize your Canister, your DFINITY Canister in other ways besides transaction fees. But I'm going to show you that there was so yeah, okay, you can see this is 66, this is 76, but then there's also a small difference at the 4th decimal place of Bitcoin, which if Bitcoin was 100K, that's actually like $100. So yeah, that does matter. You have to think if some people speculate Bitcoin to go to 1 million. Yeah, that'd be a lot for a layer 1 transaction. But okay, so I'm going to show you that it's been sent. Okay, we've received it, and yeah, we have 1 trillion satoshis or 1 Bitcoin, and then this is the next step, minting. They got to close the invoice, right? So this is letting Canister know, oh hey, Bitcoin's been sent over from layer 1, now minted over on the Bitcoin network. And then let me get my friend's address. Let's see, grab this. Your principal, sorry. Sent.
We're running out of time. Please wrap up.
Yep, so that just shows the transfer of Bitcoin. Once it's in the Canister, then it's treated the same as any other token. So we're able to process it with the same logic we use for all the other mainnet tokens. So thanks so much.
Thanks. Another great project by the Finterest team, Oliver, Andrew. Okay, so let's get moving on to the next project. Thanks again, Oliver, Andrew, the whole Finterest team. Great project also. Now, next up is Tonic, Earn, and Interesting NFT Protocol by Tonic Labs. The floor is yours.
Yeah, hello everyone. Really happy to be here. My name is Bob Bodley, and I am co-founder and chief product officer at Tonic Labs. At Tonic Labs, we have the largest NFT marketplace on the internet computer called Entrepot. We also have one of the most used wallets on the internet computer in Stoic Wallet. We have just over 20,000 unique that have interacted with our marketplace, and we've done about 30 million USD in volume in the past 9 to 12 months. But today we're talking specifically about Tonic Earn and the Interesting NFT Protocol, which is what we've built specifically for the Supernova Hackathon. The problem that we're solving, the market cap in ICP for all IC NFTs is around 3 million ICP. This is 3 million ICP that's locked up inside of generally illiquid NFTs. The only way to sell an NFT is to sell it quickly is to post below floor, and then you're taking a loss. And so I would say NFTs are generally an illiquid asset class. And we wanted to unlock this 3 million ICP in liquidity for NFTs. And we do this through Tonic Earn, powered by the Interesting NFT Protocol. So here, unlocking liquidity for users, we do that through Tonic Earn, which is essentially a front-end interface that interfaces with a decentralized protocol on the back end, which is our Interesting NFT protocol. And all of this is built 100% on the internet computer blockchain. So the Interesting NFT protocol, it's a black hole Canister, fully decentralized, 0 protocol fees, and it's all open source. So anyone can build to it, can fork it, can add on to it, can change it, and well, they can't change the protocol itself. They could fork it and change it. And importantly, there's no default risk in interacting with the protocol. You could think about Tonic Earn and the Interesting NFT protocol as kind of like an over-collateralized lending solution, where you use NFTs as collateral to borrow ICP from the protocol, and then you pay it back with interest, or if you choose not to, then you lose your collateral. So some key components of Tonic Earn, like I just said, decentralized protocol, we have ICP DeFi, and we're over collateralizing these with NFTs to grant liquidity to NFT holders. And so you can use NFTs as collateral to withdraw ICP, pay it back with interest, or lose your NFT. Or if you just want like a higher yield kind of DeFi product, you can put ICP in the protocol and get it back with interest. So here's kind of an overview of how you use Tonic Earn. I'm going to go kind of step by step and walk you through how this product works. So first, you create what we call an earn request. So Alice, let's say Alice wants some additional liquidity so that she can go hard on an NFT launch coming up. So she can lock an NFT in the interesting NFT protocol through Tonic Earn and create an earn request with a bunch of different settings. Then Bob can come along and Bob can transfer ICP into the protocol, which can then essentially he's accepting her earn requests. We call this an earn contract. ICP is then sent back to Alice. And then Alice can do one of two things. She can, at the end of the contract period, she can repay the ICP. If she repays the ICP, then she gets her NFT back and she pays her ICP plus whatever interest was specified on that particular contract, and Bob gets the ICP and interest back. Or Alice can decide to not pay off the contract, in which case the collateral for that specific earn contract, which was an NFT in this case, is sent from the protocol to Bob. So now I want to take you through a really quick demo. Everything is live here at entrepot.app/earn. So anyone can go and check it out right now. It's been live for about a week, and we've had a couple hundred people already come in and create earn requests and earn contracts. So you come to entrepot.app/earn, you can click create new request, and that creates an earn request. So you have to fill out, you pick which NFT you would like to lock up in the protocol and use as collateral. And then you select how much ICP you would like to withdraw from the protocol, what kind of reward you're willing to pay, and how long you would like for this contract to be in effect. And then you hit submit request. That's going to create an earn request. And all of these are earn requests. So you can just browse them. We have an earn tab on our marketplace, and you can browse all the different earn requests. And as a liquidity provider, you can go in and accept any of these contracts at any point in time. You can see what the floor rate is, which is essentially how much are they requesting compared to the floor of the individual NFT. You can see all of the different APRs for the contracts. And when you click accept, it essentially is minting an NFT of the contract. The earn contract as an NFT is then also tradable in the marketplace. So not only are we granting liquidity to NFT holders, but they also have liquidity with the actual earn contracts that are created. So in the real world, if Alice wants ICP for an upcoming NFT launch, or Bob wants high APR DeFi opportunities, or Carol wants to hedge her NFT bets, all of this is possible through Tonic Earn, powered by the interesting NFT protocol. Thank you.
Cool, thanks again, Bob. We can move on to our final presentation for this session, which is Spinner Cash by the Spinner team. Please go ahead, the floor is yours.
Hello everyone, we are the Spinner team, building privacy solutions on the Internet Computer blockchain. Yes, privacy is our first priority. For the most part of human history, even before money was invented, transactions is a business between two parties, because transaction is private by nature, and only public by choice. But with most blockchains, this is not the case. Now with advanced math and cryptography, we have the means to fix it. Let's take a look at how a transaction is conducted on the Bitcoin network. We have Alice here sending some tokens to Bob. Bitcoin keeps track of how many tokens you have by UTXOs, or unspent transaction outputs. Here, Alice has two UTXOs, 1.2 and 0.5. She sends 1.3 to Bob, and the remaining 0.4 back to herself. This equation makes up a transaction, where the sum of inputs must equal the sum of outputs. When Alice submits the transaction, nodes in the Bitcoin network will check the validity of this transaction against the historical records kept in the Bitcoin blockchain. We can see here the input tokens actually came from the output of some prior transactions, and they haven't been spent. So if the nodes agree that this transaction is valid, they will include it in the next block. When the next block is confirmed, we say this transaction is successful. This is basically how Bitcoin works. Now let's look at how a similar transaction can be conducted privately without revealing information to the public. Of course, this can't be done on the Bitcoin network. Here we have the same transaction created by Alice. First, our ledger has to verify that Alice actually has the ownership to the inputs she wants to spend. To that end, our ledger maintains two sets of records, nullifiers to remember what has already been spent, and commitments to remember newly created outputs. They are both only cryptographic hashes, so they do not reveal any information. Next, Alice needs to give a proof showing that she actually has some tokens corresponding to previous commitments. She also has to prove this input and output equation holds true. Once Alice has produced the proof, she sends it together with transaction data to the ledger. This includes the nullifiers and commitments used in the transaction, but not the actual amount. Then our ledger will verify the proof, and also checks against its nullifier set. This is to prevent double spending. If all checks pass, the ledger will keep record of the nullifiers of the inputs, and commitments of the outputs. In the public view, what the ledger actually sees is just a zero-knowledge proof and a set of hashes that make up the transaction. No sender or receiver, no amount of tokens. Most of the work is done at client side by the submitter of a transaction, including proof generation. This is a basic picture of essentially how private transactions are implemented in Layer 2 smart contracts, like Tornado Cash or Spinner Cash. Spinner Cash is the first Layer 2 protocol to bring private transactions to ICP, and soon to Bitcoin, supporting fully private transfers, in addition to deposits and withdrawals. You can directly launch the app from our website spinner.cash to have a first-hand experience of how it works. Simply send some ICP to the public deposit address to start using it. Now let's look at a demo of how Spinner Cash will work with Bitcoin. This runs on a local setup with the Bitcoin developer preview provided by DFINITY. On the right is a Bitcoin wallet, and on the left is the Spinner Cash app. Let's start by sending some Bitcoins to the Spinner deposit address. We create a transaction from our wallet, and wait until it is confirmed. Now our app has received the tokens, let's deposit them to Spinner's private ledger. It first creates a proof and then submits the transaction. Once it finishes, a new balance is reflected above. On the Transfer tab, you can either send to private addresses of other Spinner users, or withdraw to a public Bitcoin address. Let's withdraw 1.2 Bitcoin to our wallet. Again, the app will create a proof before submitting the transaction. Once the withdrawal is confirmed, the new balance is reflected in the app, and we should also receive the tokens in our wallet. This is only a demo. Please note that on a real Bitcoin network, deposits or withdrawals will take tens of minutes instead of seconds. But the basic workflow will be the same. Much of the smooth user experience can be attributed to Internet Computer, the platform Spinner builds on. Also, the upcoming Threshold ECDSA signature support will enable us to bring private transactions to other chains. We are very excited about this capability of supporting multiple chains from the same smart contracts environment. We also look forward to enabling token swaps between private ledgers. It is our hope that more and more people will realize that privacy is not about hiding dirty socks under the rug, but about freedom. Privacy is knowledge, and knowledge is the one thing that everyone can have and no one can take away. Knowledge is freedom. Thank you for listening. We look forward to hearing from you.
So thanks a lot again, Spinner team, for this exciting presentation and cool project. So now we've seen all the finalists of this session. It's really cool to see what kind of ideas have been around. It's also many of the things look like something being served from public cloud, so powerful it is, but it can be done on the IC blockchain. It's really exciting to see how much power this blockchain has. And essentially you can do anything you can do in public cloud, but just in a decentralized way and as scalable as cloud. So that's really cool to see. Thanks again, everybody, for the exciting presentations. Thanks also to all the other projects who have submitted work to this hackathon and didn't make it into the finals. So we are very, very happy to have seen so much high quality work. So next up for this hackathon final round is that we now have a 20-minute break where the judges will go into the backstage. So please follow me into the backstage in a minute to deliberate on the winner. And the finalists and the general audience can now go back either to the main session or go to the lobby and hang out there until the Grand Champion demo session will start at 9:50 Pacific time, 6:50 European time, or 0:50 AM Chinese time in the main session. So you have a couple of minutes break, and see you all in the main session later. And please, judges, follow me into the backstage for the scoring.